How's it going, everybody? So this talk is called Introducing RxJS6. I'm Ben Lesh, as already introduced. I am an engineer at Google. I am the RxJS lead, and I just recently joined the Angular team. Thank you very much. So here's one of the benefits of joining the Angular team. You get to watch Igor do handstands. This is a view from my desk. Like, he literally does this like 3 times a day. It's amazing. This is for me. This is the biggest what's new in RxJS, and that's because for more than a year, probably about a year and a half now, RxJS has been 100% volunteer work, almost 100% volunteer work. A lot of really good people working after hours, sacrificing time with their families working on this. And we had a lot of really great help. Actually, the only person in this list who's not a volunteer is front and center there, Jason Aiden. He's on the Angular team, and he's extremely helpful in making some of the backward compatibility stuff I'm going to talk about in a little bit. And what the Angular team has me working on is they have me working full-time on RxJS and RxJS-related Angular functionality. So that's really good news for the RxJS community, even outside of Angular, and I'm really excited about it. Something that's really important, the Angular team all wants everyone to know, even outside of Angular land, that RxJS is going to remain an independent project, and the decisions that I make on behalf of the RxJS team will be on behalf of all RxJS users, not just specific to the Angular team. It's very important to everybody. So thank you very much. So I'm going to apologize because I'm going to go pretty quickly in 20 minutes. I want to cover an awful lot of stuff. So the first thing I want to talk about is what was new in RxJS 5.5, and that came out last year. But it's really important when it comes to the migration path to RxJS 6. So this is the current stable version. In past years, whenever you were using RxJS 5 or 5.4 and under, this is what we recommended. The recommended usage was you would import observable, and you would then add your creation methods, add your operators, and you would use them. And this is fine. With 5.5 and up, we recommended that people start importing the creation methods directly and using them, like we're doing here with of. And we also recommended that you import pipeable operators and use them inside the pipe method of observable. So the question I get asked, I've been asked in the hallway a few times here, is why use pipeable operators? The big thing about pipeable operators is what they're doing is they're patching the prototype, and patching the prototype comes with a lot of problems. The problems are very specifically that it's global. So if you have a library that adds map to observable, then everybody else that consumes that observable now also has the map method. They might start relying on that, and then the library removes it, and guess what? You broke everybody else that was relying on it. So that's not good. It's not tree shakeable because there's a side effect of adding map to the prototype, and the tree shakers don't really know what to do with that. You could end up trampling somebody else's method. Say if I have a custom filter, and then we add the RxJS filter, then it's going to trample my filter. And the other things is custom operators are much, much easier to implement and use, and I'm going to show that in a minute. And also, compilers and linters will give you a little bit more help. If you import an operator and you don't use it, your linter will complain. And if you try to use an operator without importing it, your compiler is going to complain. So here's what a custom pipeable operator looks like. Here I've got a POW operator, and I'm going to show how that is actually used here in a second. But basically, you just create a higher order function that returns a function that takes an observable and returns an observable. And this is the shape of all pipeable operators. And you can use them with any other pipeable operator, including filter here that comes from RxJS. We're using our POW operator there. And POW is just multiplying a number by itself some number of times. So the old way, and I don't expect anybody to read this, the old way you would have to do this without trampling things in the prototype would be to subclass observable, add your POW method, and then override lift and make sure lift returns your custom observable, your subclass observable again. Then you have to implement a POW operator and a POW subscriber. It's a lot of work. It's clearly a lot more code than the other way was. I think this has just died. That's OK. So that was what was new in RxJS 5, and I highly recommend that you move to those because we're recommending that people use pipeable operators in RxJS 6. That's how we're doing operators. So RxJS 6 is now in release candidate. I am actually looking at probably publishing the final version of this today or sometime very, very soon. So new features in 6. So what's new in 6 is we've got new unhandled error behavior. So this is a breaking change from 5. I'm going to talk about what that means in just a minute. We also have simplified imports. We've got some deprecations and some removals. And we have a new operator, but sorry, the new operator is not that exciting. Everybody likes new stuff, but I'll talk about it in a minute. So the unhandled error behavior, this one's important. The old way that we were doing things, every previous version of RxJS did this, was if you have an unhandled error, which means an error that gets all the way down to the bottom of your chain of observation, and you don't have an error handler there, it's going to rethrow that error synchronously. And in the new version, in RxJS6, we're going to schedule that error to be rethrown with like a set timeout. So just to give you an example, say I have this bad source, this bad observable, and what it's going to do is eventually it's going to throw an error. And I didn't provide an error handler to it, that second argument. I just passed null, or maybe I have an observer that doesn't have an error method on it. In this case, if bad source happens to be totally synchronous, which it could be, I could actually wrap it in a try-catch in version 5 and under and catch the error as it's rethrown from subscribe. It would bubble all the way back out, and I could catch it there and handle it. Which is kind of weird, right? Because if bad source happens to be asynchronous, someone changes the implementation or whatever, and observables are usually asynchronous, then try-catch is not going to work. An asynchronously thrown error cannot be caught with try-catch, period. So the important thing is, for RxJS6, you do not want to depend on that synchronous error rethrowing for unhandled errors. You don't want to depend on that. It's not good. We're removing it because it comes with problems. So let's look at what you would have to do to refactor this bad pattern. So here's what we're doing here. And you'll notice inside my catch, I've taken all the logic of what we're doing in catch, and I've already kind of wrapped it in a method, or in a function rather. And what you can do is just move that function to the error handler. It's actually even less code now. And now it'll even handle errors if the error happens to be asynchronous. So this will work in RxJS6. So the moral of this story is that the code that's going to break when you upgrade to 6 around this was code that was expecting unexpected errors, which is pretty amazing. It sounds weird, but there actually is code that might do this on purpose. You could have a test, right? You could have a test that expects when you subscribe to this observable, you expect it to throw some specific error synchronously. This test will break in RxJS6 because we no longer synchronously throw errors. So to refactor this, what you would end up having to do is here I'm just passing in an observer that has an error method on it, so it's a little bit more explicit, a little bit easier to read. And then I'm testing some expectations against my error object that I've got, and I'm calling done. I'm actually making it an asynchronous test. So now it'll even cover situations where bad source might be asynchronous. So this is a little bit better to do, and it'll work in 6. So the question then becomes, but why? Why did we change the error throwing behavior? There's this little thing called producer interference, and it's one of the nastiest bugs that you'll ever come across because it's like a cross-team sort of bug that you'll see. And I ran into this at Netflix, and it was one of the reasons why there was discussions with the TC39 about why we're going to change this behavior even in the observable proposal. So just to give an example, we're going to say that we have this third-party service. This is my Jeff Cross service. It's important to name things after your friends. It's always good. So Jeff Cross service this is what the interface is like. I'm not going to get into the implementation yet, but basically it's just got this getAmazingStuff method that returns an observable of numbers, and we're going to use this amongst a bunch of different consumers. So our first consumer is the Lady Elite component, and all the Lady Elite component's doing is using the Jeff Cross service to get our observable of numbers and filtering out, trying to get all the numbers that are less than 50 and display them in some template. Our second consumer is Shy component, and Shy's mean. He's written this component, and he's not really filtering out anything. He's just using filter to be like, hey, if I get the value 42, I'm going to throw an error. Shy, come on, man. Then we have Mishko component. He's basically doing the opposite of what the Lady Elite component is doing. He wants all the values that are higher than 50 from the Jeff Cross service. So we get a bug report about this. P0, no one knows what's going on. The Mishko component randomly stops showing data. And they looked, and there's 100% code coverage. All integration tests pass. Nothing looks like it's wrong with the Mishko service. It's too simple. It only happens in production. And they suspect the Jeff Cross service is to blame. They don't know what it is. So tasked with looking at this, so let's go look at the Jeff Cross service. It's pretty simple. All it is we've got this observable stream. It's an interval. It's going in an interval. We're mapping that to a random number a random integer between 0 and 100, and we're sharing it. So we're multicasting it. So this doesn't look like there could be much wrong with this either, but I guarantee this is going to cause our producer interference problem. So what happened? Jeff Cross service returns a shared multicast observable. Multicasting loops over an array of observers and notifies each one of them by calling their next method, and that then calls other functions down your chain of observation. Shy component synchronously throws an error if it happens to get the number 42. If the synchronous error goes all the way down in the chain of observation and is unhandled, there's no error handler, then it's synchronously rethrown, which means that JavaScript is going to take over and be like, oh, well, I'm going to unwind the stack looking for a try-catch to handle my error. It unwinds the stack all the way back to the for loop that's notifying all the observers. And what happens when you throw an error in a for loop? The for loop stops. It's done. And then Mish goes sad. He doesn't get his data. And since he was the next one in that group of consumers, it's going to look like that component's the problem. So imagine if different teams developed these components and a separate team developed the service, like figuring out who is to blame for this problem. It's a very, very nasty bug to run across. Unless you happen to have me working with you, you might have a problem. So I actually have this example. You can explore it. When I get the slides out, you'll be able to just go to this stack blitz and try it out for yourself and see what the error looks like. RxJS6 solves this problem by scheduling the unhandled errors to be rethrown in a set timeout, just like this. The lingo for this is called host report errors. And what this does is it throws it in its own call stack where it can't bubble up to hit anybody's try-catch. And that means it's going to get reported to window on error or process on error where you would expect unhandled errors to go. If you still have issues with this, there is a flag. You can pull in config and flip use deprecated synchronous error handling to true. If you do that, you will get a warning in console if any library in your system is doing that. If you are a library owner, do not do this because it is global. So if you do it in your library, you're affecting everybody else that's consuming RxJS, and it's probably a peer dependency, and that's not going to be good. If you are an app owner, you might have a large app, and you're depending on synchronous error throwing in a lot of places for some reason. If you're desperate, you can try it out. But just understand it's going to affect the behavior of some of your libraries that are consuming RxJS6. So let's talk about the changes to imports. The changes to imports, this is how you imported things in version 5. So this is, again, the example. I import observable, then I patch it with the different creation methods and the operators, and I use it below. In version 5.5, you can import each operator individually, and then you can import the creation methods individually and use them like this. You could also import all of the operators from one spot from RxJS/operators in version 5.5. But the thing is, we've got a lot of different import sites. So here's a non-exhaustive list of v5 import sites. So these are all like RxJS, RxJS/Rx is the kitchen sink ones. You got observable and all the subjects. You've got schedulers, all the creation methods. These are the operators in alphabetical order. We're going to go, here's 1 page, 2 pages, 2 columns, and we only made it to F. That's the 6th letter in the alphabet, right? So, and there's multiple ways to import the operators too. So there's hundreds and hundreds and hundreds of possible import sites in RxJS version 5, and it confuses people. In RxJS version 6, there are roughly 2 that you'll care about as an Angular developer. You'll import everything that is a type or a scheduler or a helper from RxJS, and all of the operators get imported from RxJS/operators, and that's it. So here's the complete list of all the possible import sites. The top 2 I just told you about, RxJS and RxJS/operators. All of the testing stuff is under RxJS/testing. The WebSocket implementation is under RxJS/WebSocket, and the RxJS has its own Ajax implementation that nobody in the Angular community really uses because you have the HTTP service that's under RxJS/Ajax. So again, the 2 you care about, just to go over it, RxJS has all the types, all the creation methods, all of the schedulers, all of the helpers under it. Basically anything that's not an operator comes from this pretty much. And then all of the operators that you would pass to pipe come from RxJS/operators. So let's talk about deprecations and removals, the why. So the reason that we're deprecating and removing certain things is because we had some exposed implementation details that people were using. We also want to reduce the library size, and we want to reduce the API surface area so the library is a little bit easier for people to learn and use. So right now we have too many ways to do the same thing. These are all ways to do basically what observable of does. You can import array observable or scalar observable. You can use them directly with new. You could import from array, use of. I mean, this is how you use them. These are all doing the exact same thing. They even follow the same code paths in a lot of cases. In RxJS6, there's only one way to do this. You import of and you use it. So no more of this, which one do I use? There's one. Implementation details that have been moved or removed. So these are, just as an example, there's a lot of observables. Like some people were using empty observable or error observable or never observable directly. You weren't really supposed to do that. I think there's even some documentation out there that recommends you do that. It was never supposed to happen that way. These were implementation details of the library that were to support the other methods that we're recommending you use. So there's probably some people that are using these that are freaking out like, oh God, what do we do? Don't worry, we've got something to help you. I'll get to that at the end here. So deprecations, we're deprecating result selectors. A lot of people don't even know what this is, and I don't even think they were really documented that well. It's this right here. There's a set for merge map, concat map, switch map, and a few other operators. There was a second mapping function you could use to map inner and outer observables, or inner and outer values, and emit them. You can do the same thing by just using a pipe. Removing all of these result selectors resulted in removing almost 2,000 lines of code from our code base. So it's important. Now, these are just deprecated. We removed them, but we're now doing what you're seeing here internal in the library if you're still using them. But we want you by version 7 to stop using these and start doing this. So the other thing we're deprecating is the operator versions of concat and merge and zip, and the ones that basically they have a counterpart that's static. And the reason that we're removing them is there's a couple reasons, but I'll get to it in a second. So here's what they look like in operator format. You've got A, pipe, concat, B, C. If you use them statically, it's just concat A, B, C. It's a lot easier to read. So the biggest reason we want to remove them is we don't want confusion between, like, here's a creation method and here's an operator. And people try to use the creation method as an operator, and it just breaks. And you get this function is not an observable type weird error, and that's not good. So these are deprecated for now, and by version 7, we want to remove them. All right, the new operator. So exciting, throwlfEmpty. See, I can tell you're excited. throwlfEmpty, what it does is it does exactly what it sounds like. If an observable completes without emitting any values, it will map a new error and throw it down the chain of observation. If the observable gets a value, then it's just a pass-through. And this can be used in a variety of ways. Here's just a contrived example where we're saying, take all the button clicks until someone resizes the view, and if no one clicks the button before the view is resized, we're going to throw an error that said the button wasn't clicked before the view is resized. Contrived, but that's it. So those are all the changes. So great, Ben. How are we going to migrate and update everything? Like I'm ruining someone's day right now. Well, to upgrade RxJS, what you can do is you can just, if you're using yarn or npm, you can right now say RxJS at RC, and later today it'll just be RxJS, but or very soon anyways. And then right there you've already got RxJS6, and things are going to start breaking if you're using RxJS 5 features until you install RxJS-compat. And what RxJS-compat is it is a library that provides a bridge to all of the old import port sites and old types that existed in RxJS 5.5. You won't need the RC once we release, so again, that's coming very soon. And if you're using the newest version of Angular CLI, it's even easier. What you do there is you just do ng-update RxJS. And that's because we've added schematics to the RxJS library package itself that will run with ng-update and basically do the previous two steps I was showing for you. So after that, thank you very much. After that, like 99% of you will just be good to go. Even if you have the old RxJS 5.5 style, as long as you're not doing anything too crazy, it should just work at that point. So just a recap of how to migrate or update, the first thing you want to do is update to 5.5.10, the latest version of 5.5, because there's some bug fixes in there, and you want to make sure that you catch any bugs that came from those bug fixes first. And then you update to 6.0, update RxJS to 6.0, and then you can install RxJS-compat if you haven't already migrated all your code to be 6.0 compliant. And then from there, you want to go through and update your imports in your code to be 6.0 compliant, and then you can remove RxJS-compat. But Ben, there's a step in there that sounded horrible, right? Like going through and updating all your code. You don't want to do that. No, I don't want to do that either. So Minko, who's here somewhere, I have seen him around, he and Vikram and a few other wonderful people at Google have helped put together this tslint rule, RxJS-tslint, and you can actually just install it, add a migrate.tslint.json to your directory, and all these instructions are in the README for the tslint rule, and then run tslint fix, and it will go through and update all of your dot-chained operators to be pipeable operators. It'll update all of your observable.ofs to be just of. It'll make everything 6.0 compliant for you. You might have to run it more than once because there's some quirks around tslint about it'll update everything, and then you have to update everything again. But after you run it 2 or 3 times maybe, everything will be updated. Sorry about that. It's kind of funny. But everything will be updated, and from there you can probably just remove the RxJS compat package, as all your code will just automatically be updated. So another thing that people should know is right now, Google is using RxJS6 in production, the same bit that we're talking about. And we also ran these same tslint rules across thousands of files inside of Google and updated everything, and it's all working. So all of this has been thoroughly tested for you by Google because we've only got one version of RxJS inside of Google, and it's RxJS version 6 right now. So proceed with confidence that this stuff is going to work. So just a summary, you want to use the new pipeable operators in version 5.5 if you're not already. Version 6, what it gives you is simplified imports. You got reduced API surface area, and it fixes this unhandled errors problem, this producer interference problem that's really nasty. And then the migration process, the first thing you want to do, again, is update to 5.5 first and make sure that you've got all of your bugs fixed from that. And then you install RxJS at RC, or the latest version of RxJS. RxJS-compat will make all of your not compatible code, it's backwards compatibility, so it'll make your code compatible again. And then you can run the tslint rules to help you migrate and then remove that compat package. And last little bit, this bonus, this is the last thing I'm going to tell you, is there is the super secret version 7 work is now public. It's based off of Andre Staltz, my friend Andre Staltz call bags. And we're going to have the same public API, obviously minus things that we're telling you we're deprecating. But it's going to have the same safety guarantees, and it's much, much, much smaller and faster, an order of magnitude in some cases for some operators. There's an experimental branch at this link that you can go check out as far as like seeing what it looks like. And there's an active design document. It's about 10 pages long discussing like the whys and the hows of this. And I say active because occasionally I'll go through and delete like a whole paragraph and rewrite it. But just if you're curious, it's out there. So it's not hidden from anybody. That's it. Thank you very much.